All right, everyone. Welcome to Amplifying F Sharp. Amplifying F Sharp is an open source collaboration initiative that is focused on hands-on collaboration with the F Sharp community to make a difference in F Sharp. We have been running for the last year, where we focus on trying to fix specific issues on the F Sharp community. We cover topics from the F Sharp compiler, tooling, open source libraries, like Fantomas, like Fabulous, like Funk UI, like Fable. We try to really encourage everyone that has an issue while working with F Sharp to try and fix themselves that issue, and we are here to help you. And how can we help you? So if you if you go to the Join Us button, you will be able to fill this form where you can give us your name, the company you work for, your time zone, and what's the topic that you want to talk or you want to work in. So, for example, you want to have a quick fix on Ionide, or you improve a feature on the F# compiler, or a new compiler error that you think is missing. And you can basically tell us what is the issue that you are having, and we will try to help you investigate. We will try to help you fix the issue. It's not that we are going to do the job for you, but we will guide you through the first hoops, the first the initial part that might be scary for you, and then you can continue with that issue, and yeah, you can really fix it yourself and make a difference in the F# ecosystem. I myself started with the sessions on amplifying F#. While I was learning the language, I realized that the error message was not really up to the quality that I was expecting. So I contributed myself. So amplifying F# is that kind of initiative that was born with that idea to help contributors that are trying to get there, and also to help open source maintainers that they want to drive more contributions to their project, so they want to talk about some technical stuff that normally they cannot cover. So yeah, that's the main let's say topics that we have been covering in amplifying F#. But we also understood that in order to the language to grow, we need to also have an initiative that will focus on the F# essentials, and that's why we launched the initiative called F# The Essential Lectures, where we will be partnering with Ian Russell, no member of the F# community, that has an amazing book, Essential F#. And on here, we have 12 plus week of content that we have been covering. And we started with the introduction and setup, and we covered core types already. We covered the introduction to pattern matching and functions. And today, we are going to be talking about function composition with effects. If you didn't attend the previous session and this is your first session, don't worry. The previous sessions have been, as I said, live streamed to YouTube, and they are being recorded. So if you go to our YouTube channel, you follow us on Amplifying F# in YouTube, you go to the playlist, you will be able to see that there is a F# Essential Lectures playlist. And here you will find every week the previous session, where you can rewatch it, you can stop it, you can go at your own speed, and if you have any questions, just leave it on the YouTube channel. We will try to catch up those sessions and answer your questions. But today, as I say, Ian will be talking us about the function composition with effects. So Ian, the floor is yours.
Thank you, Edgar. You need to let me share.
Yep, I already enabled them.
Oh, I can't. Okay. Okay, excellent. You should be able to see my screen now. So welcome to session 3. The agenda for today is I'm going to do a quick recap on session 2, and then we'll move on to the main part of this session, which is composition with effects, really. So session 2, we did some more pattern matching, which I'm not going to show again, with tuples and records using the match expression. But the main thrust of the last session was to do with functions, so the basics of functions. And there were two things that I mentioned in there. So the first one was what I'm going to call the one rule, which is all functions have one input and one output. And it's a mathematical rule, but it's something to sort of bear in mind. And that we have two function types. We have pure and impure. Pure means that they're deterministic, so for the same input, you always get the same output, and there's no side effects. So we're aiming to write as many pure functions as we can because they're nice, because they don't do things, they don't have side effects, and they're nice and easy to test and work with and parallelize and all the rest of it. But unfortunately, you can't write an application based on purely pure functions because it wouldn't do anything. So we have to live with impure functions as well. And rather than talk about some of the other things that we did, I thought I'd go through a quick recap of what we actually did last time. So first thing we're going to look at is tuple functions. So tuple parameters. So I've got a function called add, and it's taking a tuple of parameters, taking a tuple of parameters, x and y, which are both ints, and it's returning an int. So that's the first int, that's the second, and it returns that one, and it's simply adding them up. And we need to look at the function signature. The function signature is it's taking a tuple, so there's a star in there, and of int and int, and it's returning an int. So you can tell it's a function because there's an arrow. So F# strongly typed. So the first thing that I did was I've been telling you to sort of listen to the compiler, trust the compiler. Well, the compiler can help us with this, so I don't actually need to specify the types. I'll give it a different name just so to get rid of the squiggle. So the compiler is still, if you look on the right-hand side here, it's still telling us that it's a tuple of ints and returns an int. So the next stage that I went on to was to say that actually you can put a space into there, which doesn't mean a lot, but actually turns out to be quite useful for later on. So it's still a tuple, it's still exactly the same signature. And the last one that I'll do is a slightly different style. So that's a third style using the fun keyword, and we'll use these for things like anonymous functions later on. So you wouldn't normally define your functions like this, but it's a useful tool to have in the bag that we will end up using quite a lot. So that's tupled parameters, but we can also use something called curried parameters. And this looks slightly different. So I'm going to copy that again. Right to 4. So this is slightly different in that we don't have a tuple any longer. We have what looks like two parameters. So if you look on the right-hand side here, you'll see that the signature has changed. So we've now got int to int to int. Now remember the one rule that said all functions have one input and one output. That looks like it's got two parameters. So that means there's two inputs and one output. Actually, that's not strictly true. So whilst you can use it like that, what it's actually doing is it does something called auto currying. So what it's doing is it's splitting it into multiple functions. So each function takes one parameter. So what you've actually got here is add4 is a function that takes an int that returns another function that takes an int and returns an int. Sounds a little bit awkward, sounds a little bit odd, but it has some nice little features that we can use because of that. So again, I can take that. I can get rid of the types. I'll get rid of a lot more than that. So again, the compiler can work out because it's addition. The default for addition is int, so it just works it out to be an int. And the final one that I'm going to do is following the fun style. So I'm just going to prove that that this is actually written in that way. 6. So here you can see that I've explicitly said that you can just have one parameter here, and that returns a function that takes a parameter and returns the result. So this isn't, sorry, this is, what this allows us to do is something called partial application. What partial application does, so I'm going to now use add4 in this case. Add PA equals. This is where it gets a little bit awkward because of my naming convention. So what I've done here is I've only applied one of the parameters. I've only applied the first one. You can't apply the second one instead. You have to go in order. So this has just applied the first parameter. So add PA is the function add4, and I've applied the first parameter. And what it's returned is a function that takes an int and returns an int. So to complete that, I need to add the second parameter. So if we want to add 5 and 4, I can add 5 first time and add it second time. So I don't have to do it in one go. So we're going to use partial application quite a lot in the course of this of these sessions. And in fact, we do use it later on within this as well for composition. So the next thing we're going to look at is higher order functions. So I'm going to create a new function called calculate. And what I'm going to do is I'm going to pass a function into that. So a higher order function is a function that takes another function as a parameter or returns a function. So I'm going to take a function as a parameter, and I'm going to have 2 input parameters, and I'm going to call that FAB. So what I can now do is let calculate, and if you look at the signature here, I've got what this is telling me is this is actually a generic function, but it's a function that takes. So if I cheat a little bit here, and I make. Oh, actually, I'm not going to cheat. So this is a generic function, that takes two parameters. So I need a function that takes two parameters, and I'm going to provide those two parameters. And I've already got one of those in that I've got add. And what I'm going to do is pass in, oops, I can't use add because add is tupled. So a higher order function takes another function as a parameter. So in this case, I've passed in add4, which is this function up here. What I can also do is I can create another function called multiply, and this is going to take two parameters as well. And I can put that in there as well, exactly the same. What I can also do is not create is use calculate, is actually create a function directly in here. So I can go fun, I need two parameters. So if I do, what to do I? So I do a minus b. So this again is the same thing. I can pass function. I can treat functions as values, just like other parameters. So I need to get used to that style of doing things. Next thing we covered last time was unit. So unit is used instead of, or rather, because we don't support void, because basically everything in F# is an expression. Everything returns something. So a void is nothing. But we can't have nothing. So if you imagine if you were doing a console.writeLine, something like that. So you're returning, so say you were printing out to a screen. So if we had a function called write, I'll send a message. Okay, so this is a fortuitous error. Well, it's not an error as such. So what that's telling me is that a unique overload for method writeLine couldn't be determined based on the type information. So the compiler's telling me that writeLine has some overloads. Now F# doesn't support overloads, so we need to be explicit about the type. So in this case, I'm going to pass it set it up as a string. So the compiler tells us when it can't find something out. So again, trust the compiler. What else can we do? So you'll notice there. So this is unit. So system.console.writeLine doesn't return anything, but what it actually returns is unit. So it is actually returning a value. So another one that we can look at is if you want to get datetime.now. So system dot datetime dot, let's do UTC now. Okay, because we're not using an input parameter, we still need to provide one to get the current date time whenever we call it. So we have to provide the unit parameter, which is the open bracket close bracket. So I can run that in interactive. And I get the latest date time or the current date time. The other thing that we covered as well was we covered composition. So we looked at composing functions together and using the pipeline operator. So I'm just going to compose a simple, so I'm going to do something like, so if I do 5 plus 4 multiplied by 2, but I'm going to use the functions that we've already created. So I have multiply and I'm going to use add 5 in this case. It doesn't matter which one. So what I'm doing, so I'm doing 5 and 4. So I need add. And the result of that will be multiplied by by 2. So in this case, the result of this add function is passed as the last parameter to the second function here, the multiply function. So this is using partial application, and obviously this isn't, but we could do that. I could obviously write it like this. But that looks a little bit over the top. So they're the absolute basics of functions that we need to understand. So we've got two types of we've got two types of parameters. We've got tupled and we've got curried. Which one's the best? It's difficult to say. So tuple parameters have the advantage of, well, not the advantage, but you have to provide all the parameters at the same time. So you can't partially apply against the tuple parameters, but you can against curried. Other than that, I don't think there is an advantage. Most of the .NET framework, most of the F# core rather, uses curried parameters. When we come to next week, when we do collections, you'll find that basically everything is curried because the collection is passed as the last parameter all the way through most of the functions that are used in collections. So it's probably better if you choose the curried style as the default. But it's not a hard and fast rule. And if you do parameterize in this way, you need to think about the order of the parameters as well. So that was functions 101.
We have one quick question before you
Yep.
continue. Is in the chat. It says how How was the compiler able to infer that f is a function in the function calculate? Line 28, I think.
Yep. Well, it's able to work it out because of how it's used on the right-hand side. So it's able to infer because I don't have any operators or anything in there. So the only thing f can be, is a function that takes two input parameters.
Cool, thank you.
Um, I don't think there's any other way of specifying. You can also force it. So in this case, for instance, if I knew that it was if I knew that it's int to int to int, I can actually, oops, my arrow. So I can actually type the function signature in there and force it. And that then forces the parameters to become ints because they have to match all of that.
Yeah, and we have a follow-up question that says, how can you explain how to read the function signature of calculate? And I think, based on when I started learning F#, it was always look at the last arrow. The last arrow means what will be the result of that expression of that function. So
Yep.
what it is before, in this case, in line 28, it is saying, it's int, takes an int, another int, and then returns an int. So, but yeah, there's basically, then you can have, complex functions where you need to look at, just reading from, I guess I normally read from right to left. So I know what's my return type, and then my brain goes, like, okay, what's on the left side? Is it a function that is going to be returned? Something like that, but yeah, you can explain that a little bit more
Yep.
in detail.
Yep. So as Edgar said, the thing after the last arrow is the thing that gets returned. So any function, the return value is always the last one. So everything to the left of the last thing is a set of input parameters. So this thing here says that this is a function. So the first parameter is a function. I know it's a function because it's got arrows in it. Even if there's just one arrow, that would still be a function with one input parameter, one output parameter. So you need to pass in a function that fits that signature. And then you've got two input parameters of int, and it returns an int at the end. So if I get rid of this and I go back to where we were, we find we have this funny A, B, and C. So what the compiler is able to say is this is a generic function. That's different from generics. So generics are the things in .NET that say this is the specific type of this particular thing. So you're specifying that. This is generic, as in it can take any type. So it's not doing anything that requires a specific type to be there. So in this particular case, as long as you have a function that takes an A and a B and returns a C, so this could be int, string to decimal, then as long as you pass in an int and a string, you'll get a decimal out at the other end. So it doesn't rely on the types for anything. So when it says, when you see the little dash A or tick A, that means it's a generic parameter. So something like, to make it a little bit more obvious, let's take something like swap. So swap takes a tuple of x and y and returns a tuple of y and x, and all it's done is just swap the values. So you're not doing anything with the values themselves. So therefore, any A and any B can be turned into a B and an A. So the compiler is able to work this out. So as soon as you start to use something that relies on the type, so if you have, say for instance, you add two values together, then there are a whole lot of types that don't work with that, but some do. So it can then try to infer the most correct type for you. And if it can't, it will give you an exception of some kind. So if you remember when we did this one with the system.console.writeLine. So because, as I said, because F# doesn't support overloaded parameters or it doesn't like them, it can't infer which one is the correct one to use. So you have to explicitly tell it the type of the input parameter, so it knows which one of the functions it can use.
Yep, makes a lot of sense. One of the I guess ways of the I tend to approach is like I put when I am working, I just put most of the type annotations, and then when I'm done, I'm just removing them unless the compiler is, as you say, is consuming some .NET API, and they I just left it the type. But yeah, most of the time the compiler will be able to just infer the type, and you will be good to go.
Yeah. So if the compiler can't work it out for you, it will tell you, and then the first thing to do is to put specific types in. So to force it in some way. So yeah, that's the basics of functions. Of signatures. We're actually going to use signatures a lot in this session because we have to. So that's functions. At the moment, we're going to look mainly at signatures, and as we move through, we're going to look more and more about the actual what functions do, and actually working with functions rather than just simply composing them together. At the moment, we're primarily looking at how do we build bigger functions out of smaller functions. But as we move through this, we'll actually start making functions that are useful rather than just trying to compose them together. So first thing we're going to look at today is of the new stuff is the option type. So the option type is the F# and functional programming style of program that stops us using nulls. So I've written C# since virtually it came out. A lot of the C# code that I used to write was null checks. I don't like writing lots of null checks. I much prefer this style of programming where we use options and we use the compiler to tell us when we haven't covered all the cases. So option is a generic discriminated union. The definition of it is at the top of the page here. So we've got, it's a discriminated union of type T, and it returns either some of type T or none. So it's very similar to a nullable type in C#, but it's available for any type in F#, rather than nullables are for simple primitives, and you've got the null reference types now for objects in C#. Everything in F# uses options instead. Now, obviously, we need to be able to convert from one to the other. So the first thing that I've done here is I've created two nulls. So I've got a nullable reference type, which I've had to, because F# doesn't really like null, I have to specify that it's something that is nullable. So this sort of thing happens when you use one of the when you use a library written in, say, C# or a .NET framework library. So things like system.text.json. So when you're deserializing something from that, you often end up with nulls. I do a lot of XML work. Again, when you're working with that, you end up with a lot of potential nulls. So that's what this sort of thing is for. So it's for converting from C# or .NET framework code to F# friendly code, and then from F# friendly code back to C# friendly code. Excuse me. So the first one, we've got null_obj, which is a string, and I've said it's null. And then we've got a null primitive, which is a nullable event. So I'm just going to quickly run those inside the interactive, and you can see at the bottom here that they're both null. So null does exist in F#, but it's not something that's recommended that you use at all in any way, shape, or form, unless you have to. So the first thing we want to do is we want to convert something from a null into an F# option object. And what we're going to use here is we're going to use some functions from the .NET Core library, and this is using a module. Now, we haven't met modules yet, but a module is simply something that allows us to group things together. So rather than so if you remember back to the first session, I talked about we can put functions onto types, but we tend not to. What we tend to do instead is we have types that define data, and we have functions. And what we tend to do then is to group functions inside modules that have the same name as a type. And that's what happens here. So the option type that's built into F# core has an option module, which has a series of functions that we can use. So in this case, we have two functions called of_obj and of_nullable, and they literally convert a potentially null reference object to an option type and a potentially nullable to an option type. So in this case, we know that null_obj is null, and we know that null_pry is null. So if I run those two, they both come out as none. So nulls get converted to none, and if it was non-null, it would be converted to sum and whatever the value is that was passed in. So if it's nullable int and we passed in 5, what you'd end up with is sum5. And then to get them back into a nullable object of some kind, we do the opposite. So we do option.toObj and option.toNullable. And you can see there that we've converted none back to null and null. So other uses for option, well, anything you'd use null for. So if you had, for instance, if we had a name, a simple record type, oops. So first would be a string, May not have a middle name, so we can use a string of option. And the last you have to supply. So you can do string of option like this, or you can do the other way to do it is it's up to you which way you do it. Doesn't make any difference either way. So you can use them for things that are optional values in that case. Because it's a discriminated union, we can to extract the value from an option, we'd use a pattern match, and we'll use that. I'll show you that later on as we get through this session. So that's the option type. And one of the things that we can use for the option type, so we can also use option for things like returning a value. So how about something like division? Okay, so I've created a divide function. It's just a x divided by y. So what happens if I do divide 10 by 0? So, of course, it throws an exception. So rather than doing that, what we can do instead is I can be a little bit smarter, maybe, and do a try divide. Then I'm going to say if y equals 0, then none, else. So what this is going to do is return an option event. So if I now do, that's if I do try divide. So if I highlight that, hopefully, so I now get none returned from it. And if I do 10 by 5, then I get sum of 2. So that's the option types. It's a very useful thing. One of the bad things about this, though, is in this particular case, it's fairly obvious that the only problem that we can have in this particular case is divide by 0 as a problem. But most of the code we write isn't that simple. Most of the code we write has potentially other issues in it as well, and we'd like to have some information about that problem. So we need a slightly different type that's a bit more expressive than this. And for that, we're going to use something called the result type.
Before you continue to result tab, can we answer 3 quick questions?
Well, yep. Okay.
Yeah. So I guess maybe I would try to read it aloud. So the first one is saying maybe this is from David ML and says, David, maybe I'm being picky, but we have type option with capital, but then we specify the type in the middle. It is lowercase. How is it possible because I thought F# was a case-sensitive language. I guess this might be related that we have a module on F# core called option, and
Yeah.
then we have the option that is lowercase, and then all of that.
So the type that I've defined here isn't what option actually looks like. It's slightly different than this. But this is actually just an alias, I think.
Yeah.
It's just an alias to make it look similar to all the other types that there are in.
Yeah, and also the fact that there's also, the modules in F# and .NET are always like capital K. So
Yep.
So yeah, I mean, personally, I tend to use a style guide where when I write code, and I think the style guide says that it's a string option rather than, option angle bracket the string, but it's up to you, whatever you like
Yeah.
it
Well,
or that's,
most people use string option
yeah.
rather than this style. People that start out, particularly coming from C#, will use option of string. People that have been doing F# for a while use string option.
Yeah, and the fact that IONI uses option on the inline hint at the bottom is something that might be interesting to see if that can be changed to have the same consistent inline hints information there.
Yep.
Now the next,
I don't mind either way, to be honest. It's
yeah,
as long as you're consistent, I don't think it really matters.
the next one is about performance. It says that how does wrapping and unwrapping reference type affect performance? If you have a single barrier and are not constantly wrapping and unwrapping, I imagine it shouldn't produce a noticeable overhead the way single case viewing primitive does. Yeah.
If you've got performance issues, there are ways of speeding it up. You can make them value types. There are certain other things that you can do as well. To be honest, most of the applications that we write, the network calls will be far outweighing the time that you spend doing boxing, unboxing, and all the rest of it.
Yeah.
We tend not to concentrate on performance within F#. It tends to be that the compiler produces something that's pretty good. If obviously all the performance things that you can do in C#, you can do in F# as well. So if you want to use spans and all the rest of it, yes, it's all available. But this isn't that sort of session. This is very much I write business apps. Business apps are more about writing stuff that doesn't break rather than dealing with a billion records in one go. This
Yeah.
is about shifting. This is about building things that are easy to work with, that shift, something that from a screen to a database and back again.
And definitely you can do performance. I mean, you can do performance in F#, and I am linking on the chat a YouTube to a fast F#, which is Matthew Cruz. He
Yeah,
has an amazing YouTube channel, focusing on performance, how to, measure that, how to, what's the actual, reasoning behind measuring that. And as you said, when you are developing your business line application, you just worry about the correctness rather than the performance. And then once you are running the code, you see, oh, yeah, this is a bit slow for my case. Then you can go into, measuring your functions or measuring your logic and see if that makes sense to you. So yeah, I'm going
yeah.
to.
There's a quote from the late Joe Armstrong, who was one of the guys who developed Erlang, and his idea was make it work, then make it pretty, and if you need to, make it fast. But most of the time, when you make it pretty, it'll be fast anyway.
Yeah, definitely. And the last one is, I think it's a quick one. It's how to extract the two from the sum two. And someone answered by a pattern matching. Correct
Yep,
answer, yeah.
yep. So um, Should really do this in capitals. Okay, so you can use option.get. If you absolutely know that it has to be a sum of something, don't ever do this.
Yeah.
Don't do it. No. So the way to get the value out is to pattern match. So if I do oops, so I'm much bad with okay, so yes, I'm not going to finish that off, but yes, we pattern match. It's a discriminated union. So the way to decompose a discriminated union is to use pattern matching with the match expression. Okay, so option, we've got some of something or none. What we want is something that is as expressive on the bad side as it is on the good side. So the thing to use with that is the result type. So we've got the example of option at the top. So option is a generic function, a generic discriminated union. So you return sum of t or none. What we're going to use instead is result. And result has a t success and a t failure. So it has an OK of success and an error of failure. So you can put a type against the failure as well. Excuse me. Right. So this is using the example that we used last week of the customer, and then we've got three functions called get purchases, try to promote to VIP, and increase credit of VIP. But I've made them slightly different in that two of them return results. They're also going to return exceptions as well, but exceptions as part of the result rather than throwing an exception. So we're going to cover exceptions themselves in a later session, in fact, in a couple of weeks' time. But in this particular session, all we're doing is just returning the exception. So again, don't worry about the contents of the functions. What we're primarily interested in is the signatures. So we've got a simple customer that has an ID of int, is VIP of Boolean, and credit of decimal. And what I'm doing is get purchases, takes a customer and returns a result of a tuple of customer and decimal or an exception. So in success, you're returning the tuple, and if it's a failure, we're returning the exception. So the try promote to VIP doesn't do that. So that takes a customer and decimal and returns a customer. And the last one, the increased credit of VIP, takes a customer and returns a result of either customer or exception. So either returns OK of customer or error of exception. So we then go to our upgrade customer function, which worked perfectly last time because the output from the first parameter matched the input to the next parameter, and so on down the line. In this case, it doesn't. So what we've got to do now is we can see that we've got a compiler problem here because there's a type mismatch. So try promote to VIP wants a customer and decimal, but it's not getting that. So what we need to do is, just like we decomposed the option type, what we can do now is use a match expression to try and get this to work. So what I'm going to do is copy this. And comment that out for the moment. Right. So first thing we need to do is to get access to the value. And then we're going to use a match expression. So the result passes down. So it's either OK of X or it's an error. I'll call that EX. And in the error case, we're just going to pass it down the line. We're not going to do anything with it. So the X here that we've got is a customer and decimal, a tuple of customer and decimal. So we can immediately pass that in. I'm going to write this like this with a forward pipe. Remember that all expressions have to return the same type on each path. So if you have an if expression, the then and the else have to return the same type. And in this case, a match expression, anything, each of the cases that you're testing have to return the same type. And because we're now in result world, we need to keep in result world. So if it returned an exception, we want to pass the exception down the line. If it passed the happy path, the success side, we want to actually run the function. But try promote to VIP doesn't return a result. So we need to wrap that up in with an OK. So all I've done there is to use a little bit of pattern matching with a match expression to take the value out if it's the OK path, run the function and wrap it up in an OK. And if it's the failure path, then we go on to the error path. We just pass it down the line. And what we've done now is we've moved the problem down a line. And what we're going to do is exactly the same thing. I'm going to try and get it to work this way. So if I can use the same name, it's not in scope, so it doesn't. So that value there is not the same as this one here. So again, I'm going to use a match expression. Oops. Okay, that works. So this is now sort of fixed, so I could run all this, but I'm not going to. So they're slightly different in that because increased credit if VIP returns a result, I don't need to wrap that up. It's automatically done for me, whereas the previous one is not the same. So what I want to do is I want to have a look at this match expression, because it's a bit long, it's a bit complicated, and I don't really like. I want something a little bit simpler than this. So what I'm going to do is I'm going to try and going to try and extract that out and make that a function instead. So I'm going to do this in 2 bits. So I've got this bit, and I've got this one. So they're slightly different in that because one takes a function that returns a result and one doesn't. They're slightly different functions. So let's do the top one first. So I'm going to call this function map, and it's taking a value. And I call the other function that I'm going to use bind. Let me just put that back in. Right, so what I can do now is comment that out. Oops, that's not going to work. Oops, I can't do that. I'll come back to this in a second. Right, what I want to do is I want to be able to use these things, but I want to be able to use them in a generic way. I want to be able to use them for any type of function. So at the moment, this will obviously. So if I just did map of value. Oops, value. So that would actually work because I've hard coded the name of the function into here. So what I want to do instead is I want to be able to just pass the function in. So if I call that f, I do the same with that. Let's find my function again. What am I missing?
I think you need to update the map because you update only the bind.
Yes, sorry. I have, yes.
Thank you, David.
Oops. Oops. Okay, so what I've done there is to because I'm not doing anything with the function, I can just because I wasn't doing anything specifically with try promote to VIP, I can actually replace it with just an F for any function. So going back to the function signatures, so this is now saying map is a function that if I pass in a function that takes an A and returns a B, and I return it and I pass in a value that's a result that takes that has an A or a C, so an A for success or a C for failure. What it then does is it will unwrap that A for me, run the function A to B, and return a result of B or C. So this map function is saying if I take a value that's a string or an exception, and I have a function that takes a string and returns an int, by running the map function, I get a result of int and exception. So that's how you read that. So the difference between map and bind is that map has a function that doesn't have an output that is of that effect, so result, whereas the bind one does. So that's the only difference between those two functions. And this is such a common thing in F# that actually these are built into the result module already. So I don't actually need to build these two things. Because they're already in the result module. And of course, now I'm doing value here and I'm just passing in the value at the end. I can actually get rid of all of that. So to simplify it, so that thing that we started off with, that we've expanded out, actually we can get back to this. So we can combine together functions that have effects or don't have effects, as long as they're the same effects. So I'm assuming there's a load of questions from this.
Uh, there's one, I think, but the other one, I don't think it's relevant yet. But it says, are there any rules around the simplification of removing the anonymous function? So yeah, I guess the fun value arrow, the map, and then pass the value.
So the only rule is that you're not doing anything that's, how do I put this? So the reason that I wrote this, it's the reason that I wrote this particular line in this way is because anything that fits inside here could become your function. So it doesn't have to be just the function itself. It could be any partially applied function. So actually, let's have a look at once. Where are we? 741. Okay. So I did actually do one a little earlier. Actually, I've probably got the non Okay. Right, so this is using the option type. So we're basically going to do a calculation, and it's going to be x divided by y multiplied by x and divided by y. I know that's x squared over y squared, but we're going to do it with divide and multiply. So we've got exactly the same problem as we had with the result type. So again, what I'm going to do here is so we match the value with, so we've got sum, so I'm going to call that something different. Multiply. Well, actually, we can do that. Okay, and it's telling me that obviously that's because that's a multiply doesn't return the option, but this one does, so I need to add the sum onto there, exactly the same. And then I'll do the last one. So you'll notice there that we've got a partially applied multiply function there. So this will work exactly the same. So when we get onto the map and the bind, so we'll find that we can actually use that rather than just the multiply. So match value again. So because we're passing the option down, so call that A. So we do A. Okay, I can't do that, so that needs to fit into. So I can't do. What I'm trying to do is to put the A here. So let's do. What am I missing? Oh, of course I don't need to do that, do I? Just do that. Right, so again, I'm relying on the compiler to tell me when I'm being an idiot, as I was there. So by having the fun in there, I was returning a function from a from something, and obviously wanted to return the none. So that's my first stage again. Again, what I want to do is I want to do exactly the same as I did previously. Comment that out. So again, I want a map. Bind again. Okay, so let's start working my way down the list here. So what am I missing? So again, what I need to do is I need to convert that to a function. So that works exactly the same way. And I need to do the same with this, but this isn't going to work in quite the same way. So we need f to be I think I just want that. To be So I'm just trying to think out loud here, or not think out loud. So that's definitely the correct signature. So if I go back to my result computation, so if I look over map and bind again, just want to look at the signatures. So signature goes A to B, and it's a result of AC to result, and bind is an A to a result of BC, AC, BC. So if I look at the option composition, so map is an A to B, it's an option of A, option of B. So it's a wrapped A and a wrapped B, and bind is an A to an option of B, and it's a wrapped option of A to an option of B. They're the correct signatures. Okay, so let's get this into here. So this now becomes map of that. Turns it into option. And the last one is going to be a bind of into option. Now, the reason that I have to do the function style here is because the value that's being passed down the line isn't the divisor, it's the, is that the right way around? It's the one on the top of the division, not the one on the bottom. So my calculation is divide by y. So I need to divide the value that's been passed down by the y value. So that's why we have to use this this function type. And again, didn't need to do this because actually these are built into the option module. That would be if I could spell. Okay, so these are very consistent things. So these are called effects. So things like option and result are defined as little extensions to give you extra data from a return. So if you've got something that could go wrong, rather than raise an exception for the bad case, what we do is instead we'll return an option type. Or if you want information about why it failed, it's like a business error, then we can use the result type. And we will cover that, as I said, in a couple of weeks' time when we start loading data from a data source, and we'll start doing some validation and various other things as well. So we'll start raising business errors rather than exceptions. But these patterns of map and bind are exactly the same. So as you start to compose functions with effects that don't, where the signatures don't match, and the important thing here is that when you write your functions, you don't write your functions, or you don't have to write your functions so that they do fit in and build a nice pattern, do build a nice pipeline without having to do all of this. Because once you start to understand this, then using functions like map and bind allow you to combine them together quite easily. Even though I've done it quite clumsily today, I've done it deliberately, well, partly deliberately clumsily, just to show that it's the compiler sort of helps me along the way. But it's sometimes the steps in between actually make it harder.
Yeah, definitely. When I started, I realized that when I wanted to know how map works and the bind works, I had to implement it myself, like you were doing
Yep.
there. But while doing that, I was like, there must be a built-in function for this, and then I started using like map and bind. And as you say, bind, it's I always use that when I want to do some validation. For example, I want to pass a function that it's validating I don't know, maybe a email, or I don't know, a user or something like that. So for my bind is like I want to pass the functions, I want to pass the result of that function to the next bind, to the next bind, to the next bind. And when I want to access to the actual value that has been mapped into the functions, or or in this case into the options, then I will use option.map or result.map, and I will get the result from the map, and then I can just get what I want.
Yeah, but the important thing to remember here is option.map, option.bind, result.map, result.bind. They're consistent in the way that they work, and they're actually simple functions. Most of the solutions to problems that you have in composing functions together in F# will be other functions, and they'll generally be simple functions. So the idea is that you write each individual function as well as you can, and then you compose them together. And there are lots of tools, lots of little functions, little helpers that will enable you to join things together. But it's just understanding which one to use. Now, if you get it wrong, so if I use bind here, for instance, okay, I'm actually going to get In this case, I've got an exception. But what you'll often find is that the signature will change. So can I change that to map? There you go. So what I've now got is, because map adds an option or adds a result onto the output that you've got. So what I've now got is int of option and option. So the first thing you do there would be to just convert it back to a bind. So you use the compiler to tell you that you've made a mistake. The compiler will do whatever you want it to do, but it will tell you when there's an error, but it will also, by looking at the function signatures, you can tell whether the thing is how you think it should be. So it's well worthwhile learning how to read function signatures, because composing them together, and when you're working, you can look at it and say, is that giving me the signature I expect at this particular point? So the compiler's helping you all the time with this sort of thing. Right, we've got any questions on?
We have one that I think we will be covering the next in the following sessions. It's about how you will get data from a database, using either result. How do you will model that?
So if you get data out of data, if we think about what you're going to do, so when you return data from a database, you're going to have what? So we're maybe going to send a SQL string in. So you're going to have a function that takes a string. It might take a connection string. I don't know. And it might return a result of. So let's say we're returning a customer. We've got a. So let's say we've got a function that we want to do. We want to pass in a connection string. We want to pass in an ID, which we'll say is an int. It could be a GUID, it doesn't matter. And as a result, it's going to return either. Say we're going to pass in an ID, and it's going to return a customer. Now that customer may exist or may not exist. So you're going to return a customer option. So if it's a customer, you get sum of customer. If it's not, if you can't find it, you get none. And then we've got to cover, well, what can go wrong, where you can have database errors. So we'll return the error. So making a database call is probably something like that. But yes, we will cover getting at data. So yeah, you need to think about what the so that error is probably going to be a discriminated union. So there are probably going to be potentially multiple errors that could go wrong making a database call. And then the customer option is just saying it either returns data or it doesn't. Any more questions?
It's more of a comment. It's saying that is that a bit not ideal to deal with because effects are contagious.
They are, but you also they're, how do I put this? They're when you return an exception from a function, the only way you know that there's an exception in there is either when you have to handle it, or whether you look in if you look in the code. Whereas if you've got things like results or options, the signature tells you what that function does. So throwing exceptions or raising exceptions, you don't know that the function's doing that by looking at the signature. You have to actually look inside the code to know what that function's doing. But yes, it does mean that you do that sort of thing all the way through. But we do that anyway with things like async. So asynchronous code does exactly the same. What's great about F# is that there's a library like fstoolkit.error handling that allows you to combine effects together. So it's quite possible to combine task and result, for instance. It's quite a common thing to do. Trying to do that by writing it yourself is quite difficult, and doing it in something like C# with doing the same thing is really difficult.
Yeah, definitely. I use FS toolkit, almost as I started in every project that I work on because it's such a nice library with all these helpers that you don't need to basically start. It has more composable functions that FS FR core, so it's good.
Yep. Right. So yes, you will end up using this sort of thing quite a bit, but as we get through this course, particularly towards the end, you'll find that there is another style that we use called computation expressions that hides a lot of this. So you still get the same benefits, but you don't have the you don't have the I won't call this complexity because it's not really complexity, but it's less noisy than this is. So that's it for this session. Next session, we're going to cover collections, or the main parts of collections anyway. So the next session will build on the things that we've covered in the last couple of sessions.
Yeah, sounds good. I don't think we have any other questions. So yeah, thank you everyone in the chat. It was really awesome questions, and yeah, we also had some people also answering to the questions from others, which is good. Thank you very much. Yeah, so just a little bit of context. So we are also working with reaching members of the community to, have bonus sessions about, more like once we know F# a little bit more, or once we know the basic, we can, maybe have a Fable project that, has a local database or something like that, and we will have more like a hands-on session. But yeah, I mean, it's really really awesome to have you all here, and looking forward to see you next week. So thank you, Ian. Awesome as usual. I learned a couple of things already, so which is good. So yep, I will wrap it up, and I will see you next week, guys. See ya. Bye bye.